today we're talking about springs and Hooke's law. This is a spring in its natural or equilibrium state. If a string is stretched by a force or compressed by a force, it will want to exert an equal and opposite force to return back to its equilibrium state. Hooke's law describes this relationship between force and stretching or compressing of a spring, in which F is equal to Kx, where K is the spring constant measured in newtons per meter. This means that K is equal to the amount of force in newtons required to stretch or compress a spring 1 meter, and K is equal to the change in distance that the spring was stretched or compressed. Easy enough? Let's work out a problem. A 2 centimeter spring with a spring constant of 230 newtons per meter is stretched to a total length of 3.5 centimeters. What force was needed to stretch the spring? So we have it right here. Our 2 centimeter spring, 2 centimeters, stretched to 3.5 centimeters. You can see there, 3.5 centimeters. What force was needed? So let's write down the information that we have first. We have that K is equal to 230 newtons per meter. And that the change in distance, so we see that X equal to x2 is 3.5 centimeters minus x1, which is 2 centimeters, is equal to 1.5 centimeters. But it has to be in meters since your spring constant is in meters. So we convert that to meters and we have 0.015 meters. Then you use Hooke's law to determine the force required. So you have F is equal to the spring constant, 230 newtons per meters, times the change in x in meters, which is 0.015 meters. The meters will cancel out, which will give you force in newtons. So you know you did your math right if that's correct, your units are correct. Now let's just multiply through. We have 230 newtons per meter times 0.015 meters, and you get a force equal to 3.45 newtons required to stretch the spring.